Welcome to my research project, and let's talk about networks. So networks contain information, so useful information, that are useful to solve so many different kind of problems. So let me show you two examples. On top of left, we have the worldwide air transportation network, where the nodes are the airports, and they are connected if there is an airline between them. Some guys use that network to just study the spreading of a disease. So useful. Let's go to the bottom. We have the mitochondrial metabolic network, where the nodes are mitochondrias and two nodes are connected if there is a biochemical reaction that transfers one metabolite to another. Other guys studied the structure of this network to unravel novel drug targets. So also interesting. We have networks, and if we study the structure of the networks, we obtain useful information. But as networks are complex, how we can extract this information? So one approach is to group nodes. Let's see another example. Suppose you are in the Cold War and you have all the spies in here. The nodes are the spies, and we have the messages between the spies. So one reasonable way to group these nodes of the Cold War is to group the agents from the CIA and the raid agents from the KGB. Okay, once we have grouped all the nodes, we have what is called a partition of the network. But in this partition will contain some information of the network. Let's quantify this information. This is called the stochastic block model. This square in here shows all the information from this partition. And you can see the shade of gray. So the more darker, the more probability of connection of the group. So the stochastic block model shows the probability of connection between the groups. So only by looking on this stochastic block model, we can see that in this partition there is more probability of connection inside the groups than in between the groups. So this is useful information to take into account. Then, this is what has been done until now. So people is trying to search the best stochastic block model, so the one that provides more information of the network. But we think that it's not enough. We believe that we need more than one partition to try to know all the information that a network may contain. So, as you may have noticed in here, there is some messages delivered from one organization to the other. So let's propose a different partition of the same network that considers the double agents. So we have here a different partition, a different block model that provides different information. Then we will ask ourselves, which one is the best partition? Which one is better? Well, we need this one to identify the double agents, and we need the one before to know from which organization they come from. So we need the both partitions separately, not mixed together. So what we propose to do is an algorithm, a computer algorithm, that given any kind of network, that is the air transportation network or the metabolic or this case. So any kind of network, the computer will provide different stochastic block models, each one related with his partition and providing different information of the network. Then, by having all of them separately, we will picture all the information of that the network may contain. And that's all for today. Thanks.